Okay, we move to example 6. This problem's a little different because we are no longer revolving around an axis, so using like the disk and washer method. Now what it's giving us is it's talking about some concept known as known cross sections, and we'll look at this problem. So it says find the volume of the solid shown in this picture over here. The base of the solid is the region bounded by the lines f of x equals 1 minus x over 2 and negative 1 plus x over 2 and x equals 0. So this picture down here. So you just, again, make sure you have the right picture. The cross sections perpendicular to the x-axis are equilateral triangles. So in a sense, what's happening is we have triangles that are popping out of this region here. So as you can see in this picture up here, if we kind of look at a slanted version of the x and y axis, right, we have our lines, and out of these lines are kind of bigger and bigger triangles. And so you end up with this sort of prism pyramid type object. So what we need to do here, instead of trying to figure out what our inner radii or whatever is, what we need to do is we have to integrate from our low bound to our high bound, whatever our area function is in terms of x. So this is the area function. So how do I determine the area of the little objects that I'm adding up a ton of times? In a sense is what you're trying to do. So it tells us that we're doing equilateral triangles. So for a triangle, we know that area equals 1/2 base times height. Okay, well, we don't have our height. We know that this is an equilateral triangle. There's another formula that says it's we do 1/2 AB sine C. So basically we are using trig to help figure this out. Well, in an equilateral triangle, the sine is going to be 60 degrees. And we know that our sides are the same length. We just need to figure out what those sides are in order to figure out this area function. So we're going to use this. Now this is the same thing because the sine of 60 degrees is the same thing as the square root of 3 over 2. What we're going to get is the square root of 3 over 4 times a times b, which is going to be one of our sides squared. So what we need to do is figure out what the side is. So again, follow that video back in case I lost you on how to find the area of an equilateral triangle. But what we really need, and look over to this image over here, if we know this, which is going to be one of our sides, that is going to tell us this part here. The rest of it has already been determined. We know how to find the area of a triangle, and this is specific for an equilateral triangle. If we know one of the sides, we can find the rest. So as long as we can figure out this, well, we can figure that out. So if we were to figure out one of these side lengths, that's going to be the difference in the two graphs. So it's 1 minus x over 2 minus negative 1 plus x over 2. So this, if you added these together, would be 2 minus 2x over 2, which is the same thing as x. So we can finally go and say, okay, so our volume is going to be the integral from our lower bound to our upper bound. So if we look at our picture, we know that these are going to meet, these are meeting at x equals 2. So we're integrating from 0 to 2. Our area function. So what our area function is the square root of 3 over 4 times 2 minus x squared. Now we can take the square root of 3 over 4 out and wait for later to deal with it. And so in order to make this a little easier, I'm going to go ahead and square this function so that I can apply my power rule. So if I squared this function, I would get 4 minus 4x squared plus x to the 4th. And now I can actually integrate it. So the big goal here is to figure out what my area function is. Well, because I'm talking about equilateral triangles, I went and found that area function, and then I found what I needed from the graphs to determine kind of the general form of the area. And so now let's go ahead and evaluate this. Well, 4 becomes 4x. We get negative 4/3 x cubed, and plus 1/5, 1/5 x to the 5th. And this is going to happen from 2 to 0. Sorry. So let's continue. So we get square root of 3 over 4. Our 0 part is going to zero everything out, so I'm just going to focus on 2. So 2 times 4 is 8, minus 4/3 times 8, which is 2 cubed, is going to be 32/3. And then we have plus x to the 5th, so 2 to the 5th is 32 over 5. So now we need to simplify. So we get the square root of 3/4 times, we've got 8. So if we wanted to convert all of this to being over 15, this would be 120 over 15. This would be 160 over 15. This would be 96 over 15. And a lot of this can be accomplished through the calculator, but just modeling the best I can. So this is 56 over 15. And just a little bit of simplification here. We can turn this 4 will go into 56 19 times. So we're going to get 19 times the square root of 3 over 15. Now, we don't have pi in this answer because we're not dealing with circles anymore, right? We're dealing with equilateral triangles. So this is a completely acceptable answer. The goal here is to find the area function based off what it's asking. And this is going to involve taking the difference of two curves, these two right here. Again, finding our intercepts is important. But the area function, figuring out how to determine the area is very, very important. So you're going to need to go back to some of your knowledge of geometry and try to make basic area functions. So you're not going to find the area of any of these shapes, but in the general form, if you plugged it in, if we wanted to find, the area of the triangle at this width or this width or this width, by plugging in our x, what will we do? And through this problem, we would end up going down, finally getting 19 times the square root of 3 over 15.